Hello everyone, welcome to AI Anytime channel. So this video is dedicated towards improving the RAG techniques, the retrieval augmented generation techniques, right? It's a very hot topic nowadays when it comes to generative AI, where you will be building some of the conversational interfaces, chatbots, knowledge base, some retrieval use cases, etc. Right? So it's easy to build RAG due to so many orchestration frameworks, the high-level abstract classes, the availability of LLMs and other models. But it's really tricky and complex to build a better RAG, an optimized RAG or a better RAG, mainly the retriever part and also, of course, the generation part, which is more associated toward a large language model. So in this video, we're going to look at how to enrich the metadata, right? Because metadata holds a very key aspect of the retriever part. Okay, it's very important to uh, basically look at your metadata and how you can enrich it further, right? You need a rich metadata so the retriever can understand the context, and also it's not only about performing semantic search. Nowadays, people are also building systems which involves hybrid search, right? Both semantic and keyword based search as well, where one of your part will understand the semantics behind the context, the contextual understanding, and the other one is a keyword based search, right? So that's called a hybrid search. So we'll see through some techniques how we can basically build uh, a simple pipeline that will help you add important or crucial information to your metadata in the langchain document that we create, right? So, which is the list, the page content, how to add extra keywords or the important keywords. It's not only about adding an extra keyword, and for that purpose we're going to use something called keybird. So if you look at on my screen right now, I have something called keybird. It's a minimal and easy to use keyword extraction technique that leverages bird embeddings to create keywords and key phrases that are most similar to a document. Now we're going to use this to see how we can first extract the important topics or the keywords from a set of content or your document, whatever, and how can we append our page content that we have in langchain, right, which is an orchestration framework. Same goes with llama index and the semantic kernels of the world, right? So that's the agenda of this video, guys. It's going to be a bit lengthy, but it's going to be an important video. I'll not request, I will recommend you to watch the video completely if you really want to learn it, because this is going to help you build a better retriever system as well. Now, for that, what I'm going to do is, this is going to be our source data, the source document, something called Magic Coder. That's called source code is all you need. You can see I am on papers with code. Okay, it's like a repository where you can find out a lot of the training research and different papers related to AI, machine learning, etc. Now, this is what I'm gonna look as a data source, which is Magic Coder. Source code is all you need, and you can see their paper over here on archive, archive here, and this is what I'm gonna use, okay, as a source document. I have created uh, a short content from this paper, and that is available on this notepad. You can see I'll show you a file here. Let me just open this Magic Coder. This is what I'm gonna use. So it's not completely because I wanted to save some time, okay, in the embeddings and all of those things. So I'll explain that once I'm writing. Now let's start writing the code and then we'll understand what we are going to do here. So the first thing that I'm gonna do is pip install. So let me just do that. So pip install and pip install keyword. So let me just do that keyword, and after keyword I need transformers because you're gonna use an embedding model. You can use mini LM, any other embeddings model. I'm gonna use multilingual E5, transformers, langchain, and tick token, because we're gonna look at the tokens level when we are appending the metadata, right? I'll explain that in a bit. Now once you install that, let me just have all the imports. So from we need a few things here. We need rich, we need, because this also helps you highlight the keyword, so we need a few things. So let me just do that. So from rich, import friends t range and then tqdm. Now after that we need console to print that. So from rich, import console, and then from rich.panel, import panel. From rich.markdown, import markdown. Track is fine, or we don't need progress to show a progress bar. What we need is text. So let's get import text. And so this is on the rich part. Now let's import warnings, and then we can probably ignore the warnings as well. So warnings, that filter warnings, ignore. Okay, so that's the one part. Now this is on this. Now we need date time, so import date time, and then apart from date time, what we need is need from reach dot console. Yes, this is right. From reach dot console, and we're gonna give a width of that console. So let's do that. So console equals the consoles equals your console, and here you can define the width of that. So let me just do a width of 100 or something, and this is your console. Now after that we need transformers pipeline. So from transformers, import pipeline, excuse me, this is wrong, pipeline, and what else we need is OS, and we need keyword. So from keyword, import keyword, this is right. Let's just import. It says cannot import tqdm from tqdm.rich. Okay, this is okay, what does it say? From tqdm.rich, import tqdm. This is surprising. Let me see. We have installed from tqdm.rich. Why did it say cannot import name tqdm.rich? Okay, let me just remove this and see. Okay, but this is strange. So from, it is not part of this module. From, okay, let me first see if I am able to import tqdm from tqdm, which makes sense. Okay, fine. So let's start working with, and then we'll see. But was it not part of the reach module of tqdm? It's fine. Now once you do that, now what we have to do is to get the model out. So the first is let us gets the keyword model. So kw model equals, and the model I'm going to use is of course keyword, and here you're going to define your model, and my model is let's look at, you can also use paraphrase multilingual, but I'm going to use let me see, multilingual E5. I think by its int float, that is right. I need this link. Okay, and then refine your model. Okay, kw model, it's gonna get the model. It's little slower, by the way. Okay, if you want a faster model, then you have to probably use a smaller one. But this is going to be a bit a bit smaller, bit slower as well, and it's little big. And also from a dimension wise, if you have your, if you want to use a longer context, probably this is not your an embedding model that you will use. You can use BGE embeddings, large or some other embeddings models. Okay. Uh, Now, if you want a faster, you can use the smaller ones, the paraphrase one that you were just seeing before, right? Once the suggestion was there by Colab. Now, once we do that, I'm gonna create a log file. So let me just do it. So log file, and in this log file, what I'm gonna do is basically this is the log file which I'm gonna store. So let's do that. Give some names. So keyboard log.txt. This is where I'm gonna save my log, which will be saved here in the runtime. And once we do that, the next is let's write history. So write history uh, text, which is fine. With open log file. Let's have some encoding to avoid some errors. So encoding, which would have UTF-8 encoding. This is right. And let's just write UTF-8 as file, which is correct. F.write text, and then let's just also do a bit of readability. That was right. I don't know why I didn't show it when I was writing. Whew. Okay, this makes sense, and then just close this, guys. Okay, so let me just close this. Perfectly fine. Now this makes sense. Now after that, we're gonna write a function that will extract the keys. Okay, and I already have written it to save some time, but I will explain that what's happening here. This is the main function that helps you get it. Now let me just paste, and this is available on keyboard GitHub repository as well. At least this part you can get it, this function. Now if you look at what we are doing here, we have three params here, right? One is your text, the other is the n-gram, and the third one is diversity. So n-gram and diversity are some parameter that you can control when you are working with keyboard, and based on this your topics or the keywords will get decided on. Now if you look at here what it does, it says the keyword model that we have loaded here, the multilingual E5, it says dot extract keywords. Okay? It uses a method extract keywords. In that we are passing our text, the text that will have basically the paragraph or the context, and then key phrase n-gram range. You're defining a range for the n-gram, right? If you are familiar with natural languages, would probably know it. And then we are saying, okay, look at the stop words of English. If you want to ignore the stop words, then you have marginal relevance. Okay, so that's also true. We are looking at that, helps you in diversity. Okay, for the diversity candidates, if we have worked with langchain as an orchestration, when you define your chain, etc., stuff, map re-rank, if you have worked with LOTR, like a lot of the retrieval contextual compression, that's where you use MMR kind of a thing, which is different from similarity, where you look at cosine similarities, etc. Right here you look at MMR, which is more of a technique to look at information within a space, and that's what we are saying. Okay, use MMR equals to true. That helps you with the diversity, and then we have our diversity equals to diversity, highlight equals to true. Now this will help you basically get the keywords highlighted. If you have worked with specie, named entity recognition, you also use displacey there, right? Displacey or something. If I exactly, nobody uses specie nowadays, I feel, right? Due to, I don't know, there are a lot of better models available, but anyway, but we should use that. Simplest is always better, right? So now then I have an empty list of tags. For that I'm saying for keyword, in that a, which is a variable, I'm gonna append it, right? Appending it, timestamp, etc. And then what I'm saying here is the logging one. So the logging that I'm gonna have, the file that I have, I'm saying, okay, you store like this, log down the time that you have, date time, the metadata, and the settings, whatever parameters value that I'm going to have, and then just writing it with the function. Let's run this function, guys. Now once I run this function, I'm going to use this. So for that purpose, you have to use first your text, and so let me just do it. So text, and here you have to basically define, it's like a string that I'm going to have. You can see the text here, and in below here I'm going to write. So let me first do a title. So I'm defining a structure here. So for me, the title of this paper, which is nothing but called Magic Coder, right? So let me just copy this. and I will just remove this. Doesn't make, excuse me, sorry, and remove this. Doesn't make any sense, right? So magic coder source code is all you need, and then some information like published on papers with code, and then I'm going to write authors. So let me just do, imagine if you are building a search system where you have, thousands of documents, the research papers, the manuals, those similar kind of information or data that you have, and you want to build a search system, but that search is not working properly, right? It's kind of not giving you the search results that you need. So the purpose here is, how can we enrich the metadata? How can we utilize the metadata with some crucial information that will help you on the retrieval part? That's the agenda that we are trying to, accomplish here, guys. Now, if you look at authors, now authors is, let me just copy the authors from here, okay? And I'll just remove this. I'll just remove this. By the way, if you don't know Magic Coder, right, it's an open source large language model for coding problems that has performed well on the leaderboards. But there are some issues with the Llama CPP and its uses right now with Magic Coder. But it's a good model, it's performed well on the leaderboards for the coding problems and some other evaluation benchmarks. Now, authors have been done. Let me just do a comma thingy here so you can, I don't know, I mean, what kind of name it's, okay, G. It's difficult to pronunciate, guys. Sorry for that. Some Southeast, Southeast Asian names, I don't know which country it is. Probably China or something like that. Okay, Ling Ming Jiang, or fine. Authors are good. Now after authors, let's have an URL for that. So let's have an URL, and my URL is nothing but this is the archive URL I'm gonna use. And after that, after the URL, I'm gonna copy a like a small part of the paragraph. So let me just copy it from here, and this is what I'm going to copy. You can see you have to be little aware of the context window of your embeddings as well, right? How many tokens it can accept as an input, but I think this is fine for now, just for a demo purpose. Now, what I'm doing here is I have this text. Now, imagine if this kind of text that what I have, right? Once I'm doing the chunking part, if you have this kind of information available in your vector database, how can you use the metadata to retrieve in a better way? Now, let me first show you the highlight part, the extraction of keywords. Now, once you do that, let me just write extracted keywords or something, or extracted keys, or let me just write extracted keywords. And extracted keywords would be extract keys, and then you write your text, and then if you look at the functions, it has an n-gram. I'll keep it as 1 as an n-gram for now, but you can look at other values of n-gram. It's like a trial and error kind of an experimentation. Now, and for the diversity, I'll keep it lower. The value can be from 0 and 1, so I'm going to keep it as 0.3 or 5 or something. Okay, so let me just do that. Now, this is what I'm going to keep as an values of my parameters that I have. Now, let me just run it. Now you can look at what I got from this, right? I have a title, and it gives you some highlighted keywords, which is Magic Coder, papers with code, Magic Coder again, Magic Coder LLM, open source, ChatGPT, and the duplications will be handled. I'll show that in a bit, how it will be handling the duplicates. Right now, let me just do it. Let me see if this is working. I don't know if TQDM and all of those things. Console.print. Let me just write if. I'll make it bold. So if, and you can make it bold, guys. In a this is how you define like a Python list here, but bold, and then keywords, and then just do extracted thingy. Okay, so extracted keywords. I think this should work. Let's try it out. And now you can find out, right? If you print the keywords, let me make it bigger so you can see it a bit. Now, if you look at the keywords, it's Magic Coder, open source, LLMs, papers with code, and ChatGPT. This is very helpful. It's not only helpful about for your highlighting or extracting keywords. Now, imagine if you are building a system which involves a search, like a pipeline, and you can use this to basically create tags, tags for different prompts and also the response, and basically you will also have some caching mechanism, right? So these kind of techniques will also help you from a token cost standpoint as well, right? You can reduce the cost of tokens if you look at these kind of techniques where you don't have to hit the uh, LLM every time. If you already have the information, if you have some similar tags, you can just pull the information. If it's about search, okay, of historical kind of a documents, etc., right? If your information is being changed dynamically every day or every hour of the day, then probably this will not help because those values will get changed, right? Even for these tags. Now, so imagine, for example, if you have last 20 years of records, and if you want to build a search system to reduce the burden of somebody who is working for search job, right? These kind of techniques will help you on the token cost as well. So this is also very important. Now let me just make it smaller so I can write the code. 110 is fine. Now once you do that, let me just define a file name. So my file name is nothing but this. Let me upload this file that I've created, a text file. Where is that? Okay, here we go. Okay, let me just do that, and let me just write the file name. So it is Magi coder, I don't know, source code is all you need or something. Okay, now this is my file name. It's a txt file. Let me just do that. You can see the file name over here. Okay, now once you do the file name, what I'm going to say is with open, let's open the file first. So file name, blah blah blah. I'll remove this, the right part of its file name, and encoding UTF-8 as F. This is fine. And then let me do one thing. Let me call it final text or something. Final text equals, I'm gonna read this F dot. I'm gonna reading this file F dot read, and I'm reading it. And once you read that, let's first close it. So F dot close. Perfect. Now F dot close. Let me just do that. Now once I do that, I will just do console.print. So let me just do a console.print, and once I do a console.print here, I will say text has been saved successfully or something. So text has been saved into variable. Again, let's make it bold, into final text. Perfect. Let's run it and see. And you can see now in my final text, this final text is a variable kind of a thing where I have my this, which is inside this text document. Now I'm gonna use that text document for see that how I can append the metadata, etc., and all of those things. So let's just do that. So once we do it, let me just bring up my charger. Okay. Now once we have this, guys, what we do is bring up some. Again, let's define quickly a title for this. So title, and I'll just copy it quickly. Okay, this you can see, this is fine. The title is fine. So this is my title, and then I will have file name. File name, and my file name is nothing but the txt file that I have. Okay, so let me just do a file name. This is my txt name, file name, and just defining the author here. So author, you can see now generative AI capabilities has been introduced in Colab as well, right? Now author, and after author, what we're gonna do is have the URL again. So URL is, I hope it shows me the same URL, right? Let me just do a cross verification of what I've done here. Looks good. Okay, fine. Now we have done this part. Okay, so let's run it. Now I'm gonna use langchain thingy. So from langchain.document loaders, so because we have a txt file, if you have some other files, you can also use PDF, etc. Import text loader. Let me see if it's running it. Okay, now what you also need is token text splitters. I should have imported in the same line, but it's fine. From langchain.text splitter. From langchain.character text splitter is not. Let's have a token text splitter. Token text splitter. Okay, so token text splitter. I'm just gonna run this. Now, once we run this, we need to write the text splitter thingy. So text splitter, some chunk chunk size and overlap. Kind of very intuitive thing, guys. There is no fixed way of defining this value. For example, I'll keep it. Let's keep it like 330 or something. Chunk size. I want to keep a smaller chunk size, and then you have a chunk overlap. Let's keep it 10 for now. Now this is fine. The text splitter. Then splitted text. Splitted text equal text splitter dot split text, and then our final text. Let's run it. And let me show splitted text. Can I do like this? And you can see this is your splitted text correctly, the first one, magic order part. Okay, this is fine. Now let's have an empty list of keys equals this, and here I'm gonna write for I in T range, but we didn't get the, not able to import this, right? So but let me just see if I'm able to import it from here now, from tqdm dot rich import t range. I forgot the, okay, fine. I hope I was doing some mistake, I think, when I was importing tqdm from the rich module. I think that's was a mistake from my part. Now for I in t range, from 0 to length, this is right. Splitted keys dot append, and let's don't use this right now. Okay, let me just do one thing. Splitted text, and once we do the splitted text, let me just do a text here. Okay. There is something wrong with the indentation also, to text, and then text equals splitted text and I. This is correct. Now this, let me just remove this. There was some mistake in intent. Now text equals splitted text I, keys dot append, and in this keys dot append I'm going to write a lot of things. Okay, the first is documents. So document, your document is nothing but the file name, and after that you have your document file name, then you have title, and title is nothing but the title, and what else we have? We have URL author. So author equals author, then we have URL equals URL. Right now, after that we have doc equal nothing but the text that we have, the splitted text I, and then we have your keyword. Okay, so let me just write keywords, and this is nothing but the extract function that we have written on top. So extract keys, and within this I'm gonna pass my text, I'm gonna pass my, let's keep 1 and 0.35 here. Okay, now this is my thingy. Okay, now this is keys dot append, and this looks nice. Now let me run it. Now you can see it says 2 by 5, right? It means that it's creating for all of the document text that I have, right? All the content from the txt file that we have. Now if you have a bigger one, it will take a bit of time, right? But you can see so many highlighted one, and we'll figure it out in a bit. Now let me just do one thing. Let me just do console.print and keys, and here I'm gonna write 1. Let's see that. Now for this part, okay, you can look at ChatGPT programming LLM 2022 synthetic, right? This is your doc, and now if you use this as a langchain document, kind of, langchain doc, on top of which you're gonna basically create a vector store and retrieve, because when you use langchain, the metadata only is nothing but your source document file name. That's the only metadata by default. That's by default, but there are ways you can add it, and this is also one of the ways that you can, add more information to your metadata, which is very important. Because if you only keep source file name, right, your document file name, it will probably not help you in complex use cases if you are working on to improve your RAG pipeline, right? This is why it's very important. Now let's create the document database, and I show you. Now if you look at the, let me first do a first one and show you. This was the second one. Now if I look at the first one, let me make it a bit bigger. Now, if you see, it says the document, which is your file name, then the title of this, and then the author, then the URL, and this is the doc. Basically, this is your only doc if you use langchain by default without any extra, pre-processing kind of a thing, right? That's what we are doing here. Now, if you look at keywords, this is the extracted keywords coming from keybird, and now this will be part of your langchain document as well, the database. Let's write code for that. Let me make it a bit smaller, and here I'm going to write now from langchain, langchain dot schema, langchain dot schema dot document import to document. Let's import that. Basically, you have to define the schema, and langchain gives you this ability to define that from scratch. You can define your custom thingy as well. How should your metadata looks like? How should be the structure of your document that you're gonna create a vector database or a vector store, right? You store that embeddings on top of it. Now, that's the beauty of langchain that provides, and that's what we're gonna utilize here. So let me just write like final docs. Okay, final docs, and in this final docs, it's again an empty list. And in this empty list, I'm gonna have for I in range, excuse me, let's stop using I, guys, in for loop. Okay, for I in range, this is fine. Okay, so length of keys, which is okay. Then we have final docs dot append and document, and then keys. Probably this should work. Let me see it once. Okay, if not, then we can console dot print final docs I. Let's see it. Okay, it says one validation error for document field required type value error dot missing. Okay, because let's define that then everything. Now, final docs dot append and document. I'll just remove this part from here now. Document, and this document, the thing is page content. So let me just do a page content, and the page content is where you define your keys, right? Actually, I got it, the error. Now this is you need page content, by the way. If you use langchain, you will see that context of the page content, which is a Python list kind of a thing. Now keys, and this goes your keys I, and then goes your docs. So this becomes your page content docs. And is it docs or is it doc? Is it doc? That's doc, not doc. Doc, and after that, I hope this makes sense. Page content, then you have your document, page content, metadata. So metadata, and that's where we are coming, right? It's a dictionary, guys. So in the metadata part, I'm gonna first have my source, and source is basically, let me just write keys, and source is nothing but the document. That's your source. Okay, document, and then next goes your type. So let me just do a chunk here. So type is chunk, type chunk, and then after type we have title. So let me just do a title, and title will be again for keys I title. Keys I title, keys I title, then author. So bad, it's not showing me the suggestions now. Author, then keys I author. Let me just write it quickly. Keep the right author, and after author we have URL. So let me just do URL, and then keys I URL for all the I, guys, basically all the items that we have, right? And then basically your URL, and after URL what I'm going to do is, after URL then you need keywords. Keywords, keys I, and here I'm going to use my keywords, and that's all. I think this is fine. and then let me run it first, and let me just do console dot print final docs. Let me just run it and see. Fantastic. Now let me just make it a bit bigger so you can see it, and I'll just remove this part, or let me just close this, by the way. Okay, not required. Now if you look at the metadata, now the page content, and you can compare this with langchain default one, right, where you don't add this information in your metadata. In your metadata, only file name will be there, whatever file name that you have as a source document. That's what you do as source return documents equals to true or something, right, when you use with some retrieval chains. Now if you look at now what we are doing, we have a title, we have author, we have URL, and we have keywords, which is your extracted keywords, and that's also with some weights assigned to it. And that weights can be, traditionally through natural language attributes like n-gram, diversity. You always don't need what you understand by weights in deep learning, right? Now these have some weightage, the way the algorithms works when we use keyword. Now this is important. Imagine if you are working on some, as I explained earlier, right, some search system or some retriever. This will really help you. It will also help you if you build a hybrid search where you're also not only looking at the semantics behind this page content, this a contextual meaning behind this, but you can also combine these keywords. For example, magic order, then you just return this and give it to an LLM to make it more human-like response or synthesize the response. And that's why it is very, very important, guys. Now let me just do one here and see, and this is what we wanted to build in this. You can see ChatGPT, programming, LLMs 2022, and synthetic. I think there will be only one more. Let's try it out and see. And you can see it, instruct heuristics evolved ChatGPT code llama, which is fantastic, right? I mean, you can look at the now it has become enrich. It's really rich when it comes to having a rich metadata using keyword. Now what we did in this, guys, we used keyword, which you can find it out over here. Which is a library, which is a keyword extraction technique that leverages bird embeddings to create keywords and key phrases that are most similar to your document. So document is nothing but this one, right? This is your document. This is your document. Okay. Now this is what we did here. If you want to use this part, if you're working on some topic modeling use cases, if you want to find out some tags, you can use this keyword as well. I wanted to create a single video, but this can be a separate video as well, right? How to extract highlighted keywords or important keywords from a set of paragraphs or document. You can use keyword for that as well. But I wanted to focus more on how this is going to help you in the RAG pipeline. Everybody is talking about RAG. You should also start building it, right? So you can find it out over here, the keywords and page content. That's all for this experimentation, guys. The video, if you have watched it completely, if you like the video, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel. And I have more than 25 videos on RAG. You can have a look mainly with open source stack and also with closed source, a lot of deployments video and LLMs video. You can find it on the channel. This notebook will be available on my GitHub repository. I'll give the link in description. And yeah, that's all. If you have any thoughts, feedbacks, please let me know in the comment box. Thank you so much for watching. See you in the next one.